Let's talk about the idea of integrating an absolute value function. Integrate the absolute value of this thing. Well, right away you should go, huh? Because that looks kind of weird. You're not used to seeing something like that. But what you really need to do is interpret this meaning to figure out what it is. First of all, let's take a look at simply f of x equals x squared minus 1 before I start talking about the absolute value. That function is going to be down here at -1, and it's going to look like this. And this is also a -1 here and a +1 here. So if I simply integrate this from -2 to 2, here's -2, out here is 2, what's going to happen is this is going to be a positive, this could be negative, this could be negative, this is going to be a positive. If this again was a profit and loss function, it would make sense. But that's not what it's asking for. It's asking for the absolute value of it. Well, the absolute value is going to take this piece right here that's below the x-axis. Remember, the absolute value takes everything that's negative and makes it positive. So it's going to simply go like this. So now this absolute value function is going to look like that. So all this area is positive, this area is positive, this area is positive, this area is positive. Now to actually do this, I need to break this up into 3 different components. I would first have to integrate from -2 to 1, -1 of x squared plus 1, minus 1 dx. Then I'm going to add that to the integral from -1 to 1 of x squared minus 1 dx. However, this, as I wrote it, would have brought me down here in the red. So what I need to do to account for this absolute value is take the negative of this area. So rather than adding, I'm going to subtract, because this will give me a positive contribution, this will give me a negative contribution. So the double negatives gives me a positive contribution, which is what I want up here. Then of course I'm going to add that to this last segment, which would be the integral from 1 to 2 of x squared minus 1 dx. And that would actually give me all of the area between the curve and the x-axis of the absolute value of x squared minus 1. Now, currently, we're limited to the idea of integrating areas that we can only find geometrically. Okay, so right now, we're limited to only geometric. Or by taking the limit of a sum. So if I take a Riemann sum and then take the limit as n goes to infinity, then I could actually find that area. That's going to all change very quickly here when we introduce the idea of the fundamental theorem of calculus. The fundamental theorem of calculus is going to change everything for us in the way we go about actually finding areas under the curve.